الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmena.
Assalamu alaikum, good evening, Masā al-Khair everyone. Welcome to another session on Google Cloud with the GDG MENA Digital Days. My name is Nabil, for the ones who don't know me. Today we're going to have another topic on GCP. We did have some kind of feedbacks after a few sessions that probably we're doing some advanced topics. Today we're taking it a little bit back, doing some simple things in some of the services on the networking. Today, we're gonna give you a chance to have some practice with one of the networking services in Google Cloud, which is load balancers. So, first of all, I'm gonna do a little bit of introduction, and I'm gonna be sharing some links to allow you to work on quick labs, to do some labs, and get the opportunity to achieve what we call skill badges, and I'm going to go through that process when we cover the topic of load balancers. I'm going to keep an eye on the chat window to see if there is any questions. So first thing first, before we talk about load balancers, we need to understand why do we need to load balance? What is the purpose of load balancers? What are they there to solve? Help us to serve our applications to users. So load balancers, they are basically a service that we use if we are providing applications to our users on the internet. And these users would be coming from different locations, and we will be serving our applications or hosting them in a particular region, and then as the load, as the demand gets more for our application, we need to balance the load to where this application is hosted. And usually what the application get hosted in servers, virtual machines, and we need to scale and balance the load that is coming to my application depending on some kind of metrics that we're going to be using. So in Google Cloud, the service that sits really well with the load balances is obviously virtual machines. And under virtual machines, we have what we call instance groups. So instance groups is a set or a group of virtual machines that they would be sharing the same configuration in terms of CPU, memory, storage, operating system that are running, application running on them. And as we need more virtual machines to serve our customers, our users who are coming to consume our application, we need to give them more virtual machines in order to respond to their requests in an efficient manner. We don't want users to be waiting for virtual machines to come for a long time in order to have that scale. So managed instance groups, like I said, is a set of virtual machines that will help us to scale. And they come with many features. So you can see in this example here, let me just get my laser pointer. So this is kind of a set of virtual machines, web server, for example, running a web server that will be hosting our web server web application. And they will be, you can see they're based on a template. So a template is basically just source of a VM. So if we have this instance group, we'll have what we call an autoscaler. And if an autoscaler, we ask an autoscaler to give us more machines, then he would ask you what kind of specification we want, what configuration we need for the virtual machine to be added. And this template, what is gonna give us this configuration, the CPU, memory, disk, operating system, and the network, the region where it needs to be, and the rest of it. So once we have a requirement to auto scale, the autoscaler will pick up this configuration from this template and create a new VM for us. It can be, this instance group can be in one region, and it could be in one zone, and we discussed that before. So let me just bring the console in here. So let me share this. So this is the Google Cloud Console. And if I go Compute Engine, and I go, you can see here, I've got VM instances, normal VMs that I'm gonna be using, instance templates. And so I've got an instance template just like a VM, so I've got a few of them here. If I just open one, you will see that it's just a specification for a virtual machine, a name, machine type, CPU, the zone, the network that is on, the boot disk, what kind of operating system. So normal stuff, really just like a virtual machine. I've got two ways to create a managed instance group. Either directly from here, I can go create instance group from this one, or the other one, I can go to the instance group, and I would create an instance group from here, and I give it a name. Okay. And I specify the template that is going to be used for that. So I can go one that is available. Yeah, template in here. Maybe I should make this a little bit bigger. And then I decide about the auto scaling. So I've got, I can put it in a single zone, which means one data center, which is, you know, in the production environment, you might have like in this situation, a single point of failure. If that zone, have a failure in there, I've lost my application on my machines. So I can go with multiple zones, which means we are saying we're distributing our virtual machines from this instance group into different data centers in one region. In this case, we're using US Central 1, and I can decide to go for even distribution, which means if I start minimum virtual machines that get hosted in, like if I say 6, maximum 10, it's gonna basically put 2 virtual machines for each of these zones. The other thing I can do here is how do I control how do I auto scale? So auto scaling in this case, based on this auto scaling metrics, this is what the auto scaler, which is based on this instance group, will be looking at. And I can decide on different things. I can go and say CPU utilization. So imagine that I've got my application running on this 6 virtual machines to start with. So multiple users coming to different VMs, because remember, we're going to come to the topic of load balance, and I'm going to load balance my load, which means some users are going to be using my application that is in one VM, in one data center, the other ones are here. So basically distributing the load across them. So we're not hitting one virtual machine that could be overwhelmed and it's going to crash my application. So this is the idea behind having multiple virtual machines sitting behind the load balancer, and the load will be kind of load balance across all these VMs. So how does the auto scaler know when do we need more virtual machines? And these metrics, this is what dictates what are these metrics that I'm going to be using in order to auto scale. So for instance, here we have, for example, the CPU utilization as a metric, which means we are saying if the average CPU utilization across all the VMs that we are starting goes above, in this instance, I can say 60% or 40 or whatever the case might be, then the autoscaler, it will trigger the creation of a virtual machine based on the template that we specified, and it will give me another virtual machine, and it will basically load balance the load that is coming from the load balancer to give more of those requests to the new virtual machine. And this will bring the utilization down from 60%. The other metrics that I can have here is HTTP load balancer utilization. So according to how much load I've got on my load balancer, those requests come into the load balancer, then from there, I will specify percentage in here, our utilization percentage, and it will be my target, my trigger, the metric to be able to do that. Or I can specify any metric from my monitoring. I can bring up any metric. I can use a combination of multiple metrics in there. And this all, you might be asking the question, how do I figure out where is the trigger? When do I need to trigger? And this is where testing comes into play. So you will test your application, you do stress tests, you workload test on your application, and see where is the performance points where you need to auto scale. So for this purpose of this demo, we keep CPU utilization 60%, and then I can add other metrics and things like that. So we got also this cooldown period here. This is another one that is important. So imagine when you have a new virtual machine added to this instance group, obviously it is going to take time to the operating system to come up, the application that is running on that virtual machine to initialize. So it does require time to come up. And for that particular reason, I need to give it enough time in order to be considered as part of the instance group. So the calculation of that metric, the threshold, it will be done only when this cooldown period has passed. So if I know that my virtual machine will take 1.5 minutes, I need to put 90 seconds in this field in here. If I leave it 60 seconds, basically what I'm saying, give me virtual machine, but again, 60 seconds comes and the autoscaler will see that the CPU is still 60% above that. So it will give me another one, but I don't need 2. So it will go in this cycle where it when it gets me one virtual machine, and all of a sudden you say, okay, it's now less than 60%, it will take that virtual machine. So it will go into that cycle that is not going to be stable, adding virtual machines and removing them without needing to do that process. So we need to make sure that the cooldown period and the time where the application is ready to take the application matches. So I need to cover for that period. And I can do things like health checks for my VMs, make sure they are running. So auto heating, which means that I'm checking my virtual machines all the time. If virtual machine is down, I need to take it out from the instance group, or I need to reboot it and things like that. So a lot of auto functionality in here that I can do. So these are kind of the autoscalers, the managed instance group. That's the idea behind them. So that's what we're saying here. The templates, the instance template is just like a VM. So you select the name, CPU and memory that is required for that, and anything that you require for that virtual machine that will be used by the autoscaler. So we've seen that, the instance group to select that, the health checks, and so on and so forth. And this is the example that I was giving. So this is how it works. So if you're using the average CPU over the virtual machine 60%, then if it's above that, I've got two virtual machines, then I need another one, and then all of a sudden the CPU is now 75. I need to be below 75%, which this kind of new VM is going to allow me to have that. Like I said, these auto scaling policies, CPU utilization, load balancing, any monitoring metric, queue-based workloads, another one that is important, coming from things like PubSub messaging system. So if you're expecting a lot of messages from PubSub, for example, I need to do this queue-based workload. So I need to measure before they hit my managed instance groups. I know what's the load that is waiting for me. So I can measure that and be ready for that load before it hits my instance group. So I'll auto scale beforehand. So another one that is useful. And again, you can increase the load. When the load increases, you basically have more VMs. You add more instances, and when it decreases, you basically remove those instances, so you're not paying for them. Okay, now that we understand the scaling part of it, and these instance groups, I can put them in different regions, depending on where is my user base is that is consuming my application. And ideally, if I'm going to have a global user base, I'm going to be using what we call an HTTPS load balancer. So HTTPS has got a global scope. So if I'm having a web application that is serving users in the US, in Europe, in Asia, in Australia, what I will do, I will create instance groups in all those regions. So I'm making basically my users near the resources, so I'm minimizing latency. But then how do you get users to get to the right instance groups? This is the role of the load balancer. The load balancer works on what we call an Anycast IP address. I'm going to explain on Anycast IP address in a second. I want to do a global load balancing, so it doesn't matter what my user is. I want to send them to my application, ideally give them resources near where they are, so to minimize latency. And obviously, HTTP load balancer, they support these multiple ports, port 80, 880 for HTTP, HTTPS for port 443, coming from clients IPv4, IPv6. Termination will happen at the load balancer. So inside the Google network, only IPv4 IP addresses are supported. And then the auto scaling, obviously, this is supported. We're talking about the HTTP load balancer. So auto scaling here depend not on the instance group that we talked about, but the load balancer as a service will auto scale without pre-warming. So depending on the load, it's completely serverless. You don't have to manage any infrastructure for the load balancer itself. Not like when you are on premises, then you might have like instances that you need to create in order to manage the load, but also, for example, for AWS, for example, the load balancer is instance-based, so it does require pre-warming. Here in GCP, there is no pre-warming required. And also you can use URL maps, and I will explain URL maps for that load balancer in a second. What the purpose of that, because it's another one that is super important to efficiently use resources efficiently in GCP. And then again, you will have backend service as part of the load balancer, where you can have the health checks. So the health check, basically, the load balancer will be checking the backend instances to make sure that are these VM that I'm going to send this user request to, are they healthy or not? If they're not healthy, so they're not going to be sending requests to their session affinity, or what we call sticky sessions. This is another important feature that you can leverage. It's optional. There is other ways, other Google services, maybe for another session, to discuss how to use session affinity, how to go around session affinity, because session affinity has got advantages, it's got disadvantages. But for the purpose of this session, we will talk about session affinity, basically to have. Let me just give you an example here. You might have like a web application, but a user, for example, you have a shopping cart that is online, and a user is buying some products from your online store. So they selected multiple items, colors, number of items, prices. So, and they go to the the shopping cart is ready for execution, basically waiting just to pay and finish the transaction. For a reason or the other, the user got busy with something and the session got timed out. So when it gets timed out, they need to log in again. Now, if they log in again and that request, for example, gets sent to another server, he will find that shopping cart empty. So ideally what you want, which could be very annoying for end users. So ideally what you want to do is to send that user to the server where he has the first thing, the session. So ideally you would want to have the user going back and find the shopping cart when they log in back on the same as he wants. You don't want to start from scratch. And this is what the session affinity will be available to them, or sticky session. So stick that session to the server where they came back to. You got the timeout for those sessions in here by default 30 seconds. And as the back end, where I'm going to be sending the users from my load balancers, you can use instance groups like we've seen. You've got a balancing mode, capacity scaler, so all those kind of features of the load balancer. Obviously, there are other things that you need to be mindful of here. So the target proxy, this is what's going to be proxying your session into the instance groups. You need SSL certificates for security. Another one, quick transport. I'd highly recommend to read about the quick transport layer protocol. Another super important protocol from networking load balancers as well. I'm not going to talk too much about these. And remember last time we had Cloud Armor. We talked about Cloud Armor as another layer of security that you can leverage on top of the back end. Previously, we talked about firewall rules as well. So when we talk about these different security layers in GCP, if we take, for example, firewall rules, we said they apply at VM instances. Sorry, camera on? Yeah. And let me just see what's going on here. There you go. Yeah, sorry about that. Yeah, so we talked about firewall rules, and we said they are applied at VM instance level, which means I have some traffic coming in, and I will decide, am I allowing the traffic in or not, based on the source where this traffic is coming from, the ports that I need to open or close, egress or ingress, this kind of stuff. We talked about that. But when we talk about firewall rules, what we're saying here, the traffic is already in my network. So I want to stop any unauthorized traffic at the edge of my network. And this is what the load balancer will give you some kind of that, because from security perspective, if I take an HTTP load balancer, any traffic that is not HTTP, the load balancer will reject it. So that's one way to do it. So I'm not getting to the load balancer, to the backend VMs. But also, like we spoke about Cloud Armor last time, another layer of security that sits beyond the load balancer at the edge of my network. So it's going to block the traffic closer to where the attack is coming from. So I can do whitelisting, blacklisting. I can even, like I said last time, block a complete geographical area. If I didn't want traffic coming from a particular country, I can, okay, my application is not serving that country, I can block a complete country. And the Cloud Armor, another one that I can configure with the load balancer. Very, very easy to use, very, very easy to configure. And another one with the load balancers is, from security perspective, they've got Ddos protection by default. I don't have to configure anything. So Ddos application attacks, they're blocked and mitigated by default. I don't have to configure anything. Got this intelligence where it will throttle the traffic if an attack is purposely coming to my network. In some instances, you can even drop that traffic if it's coming from an attack. So, and this is done by default for me. So like I said, for when we talk about the Cloud Armor configuration, I can do blacklisting, I can do allow whitelisting to allow source of IPs, support both IPv4, IPv6, and the response code that I can do deny rule. I can respond with 403, 404, or 502 error codes, and I can set some rule priorities for different rules as well. Cloud Cdn is another service that I can leverage with load balancers. So I can put a load balancer and I can have caching of my content. So content delivery network is another service that Google, they use for YouTube, for example. So they cache content in different regions and making content closer to users. And again, this is another service that is, from security perspective, I am kind of putting my content across the globe. So it would be difficult to have a DDoS attack, so somebody overwhelm all those regions when my application or my content is served in multiple regions. So for Google, for YouTube, for example, let's say somebody is in Tokyo, for example, uploaded the video and somebody want to watch in Belgium, then the content, when he uploaded, it will be cached in all those locations. So the user is in Europe somewhere, they're not going to be streaming that video from Tokyo. They will be streaming it to the location near where they are. So bringing latency down. And that's why, for example, in YouTube, you never see buffering and things like that. If you see that, that means your network internet connection is poor, not the video that you are watching. And this is basically how it works. So caching contents with Cloud Cdn. We'll have a load balancer. We have here different instance groups in different regions. And basically the load balancer will be basically saying that sending the user to the region, the instance group that is close to them. And I can use caching of my content as well, just with the tick box that as part of the configuration of the load balancer. So the intelligence that I have in the load balancer in the sense where in this particular case, user in San Francisco, when they use the IP address, when they need to log into the application, they will be sent to US Central 1 instance group. So they don't have to, the load balancer will figure out the geographical location of that user. Somebody who is in Asia, they will be sent to Asia. Somebody who is in US East 1, they're going to be sent to the backend that is US East 1. And this is basically what we said earlier, the Anycast IP address. So it's not a real IP address that is configured to a particular location or a physical appliance or anything like that. Anycast is basically used to proxy the traffic, to route the traffic to the closest location where the users needs to be. And this is another example how the under the hood how it's going to be working. So you will have different instance group in different regions, and depending where the user is coming from, is going to be sent back to the right instance groups in the backend in that particular region. So let me just go back here a little bit here. Some questions might happen is when we said we created instance groups. And we said we specify the minimum number of VMs, the maximum number of VMs. What happens in the case of if I reached full capacity of an instance group? And in that case, what the load balancer will do is it will check and you say, okay, I've got full capacity here. I won't be sending these users to this instance group because it's full. I'm going to send the user request to the next closest geographical location where they are. So in that case, if I had another one in Europe, probably the user in San Francisco, if he hits in the load balancer, probably is going to be sent to the Europe one, not the Asia one. Or if it's if the instance group is completely down, this is where the user is going to be sent to the next closest instance group that is serving that request. So that's in general load balancers, how they work, specifically the HTTP load balancer. The other types of load balancer that we have in GCP, you will have different types depending on the scope. Am I going to load balance across a region? Let's say in one region in Europe or one region in Asia, let's say it's London or Frankfurt or whatever that might be, or is it global? So that's the first decision I need to make. So this decision tree will help you to be able to decide which load balancer would you be using. And then you'll be looking at, am I doing internal load balancing for maybe I've got a middleware application and then I've got a back end and I want to load balance internally. So I've got internal load balancers, I've got external load balancers. And also, depending on the traffic and the ports that is you want to be supported by the load balancer. Is it HTTP? Is it HTTPS? Is it TCP traffic? Is it UDP traffic? So what is my application doing? What kind of traffic I need to have in here? So this is another kind of a really good decision tree to help us make that decision. But also I've got this table as well that's going to help us to do that. So you would know what ports that need to be supported. Is it internal or external, regional or global? And what kind of traffic types of TCP, UDP, HTTPS? And then I'll make an informed decision of what kind of load balancer I need: HTTPS, SSL, TCP, network TCP, UDP, internal HTTPS. So a very wide range of selection that I can leverage for my application that I want to serve my users. So with that, I think I will give you a chance to start using load balancers and things. So let me just go back and try to find out the link. I'm going to be sharing it in there. Are you going there?
Private and private chat. Internal load balancers, right?
Yes.
So find it on private chat. Sure.
So 1 second. So I need them to. I need to go to. Give me a moment. I'll be sharing with you in the chat is the link where you need to go. 1 second, because they need to run a lab for 5 minutes. Okay, okay. So what we need to go to copy this link. Let me put that in. Let me see if there is any questions in there. It's not that. I need to put this link here. If you use the second link, the quests, Cloud Skill Boost, Quest 31. Sign in. Are we going for the internal? Because I go with the HTTP with Cloud Armor. That's why I explained. Just sign in. And if we start this now, so
Do you have a token?
yeah, so what I'm going to be doing, I want to, if anybody wants access to this, if they can send us an email to GDG words. If you put the email address in the chat, in the private chat. So what we ask you to do, we give you credit to start using the lab. So the idea.
Token?
They send us an email, and we're going to share credits with them. They will be able to. You see what I'm saying? So what I'm asking you to do is.
It's not there. On my GG.
Okay, I'll use mine. Okay, here's mine. So if you need credit to use this lab,
Write it down.
okay. You put it in the private chat. Send us an email to, because what you're going to need what we're going to be doing here is you're going to need the credits. So it's going to ask you for a token or a credit. So in order for us to share some credit with you, we're going to share an email address with you here. So send us an email, we're going to add you and share some credits with you so you'll be able to do the lab with us. But in the meantime, let me explain a little bit about this skill badges. Did you share that? The email address?
Yeah, sure.
So skill badges is it's a really good initiative by Google Cloud. So what we're going to do here, when you go to this link, you just enroll to the quest. When you get quest number 1, and then go back and start the other lab, and we're going to be sharing some credits. But the idea behind it is quests are skill badges, basically just to give you ability to upskill in this domain of networking in Google Cloud. So you will have a set of labs that you will be doing, and each lab is covering different topics. So today, for example, we covered load balancers. Last time we covered Cloud Armor, so it makes sense to do this lab now. Internal load balancers, cloud packet mirroring, VPC network controlling access, how to use multiple VPCs, user authentication. So when you do all these labs, basically you will get a skill badge. So a skill badge is to demonstrate that you've got the skills in Google networking to do all these tasks. So when you complete it, you will get this badge, and you can basically showcase that into your social media accounts, and basically starting to get more skills in Google Cloud. So once you get the credits, we're waiting for your emails to come through. So gdgclouduae@gmail.com. Oh, okay. If you go to YouTube, on YouTube, GDG MENA. Yeah, can you share the link? Yeah, we're gonna show you what that link is. So the lab that we're going to be doing is HTTP load balancer with Cloud Armor. So once you get here, we're just waiting for the emails. We'll be sharing some credit with you. So the idea that when you start the lab, we're going to give you credits to launch that. 5 credits, we're going to give you more because you need to do all the labs for the skill badge. And the skill badge, you have 1 month to do it. So you can do 1 lab or 2 every week. Take your time. And basically what you will see here, the quick labs environment I'm going to be doing is not simulation. So you do get provisioned real resources. So when you start the lab, just waiting if any messages are coming through. Let me see. So if you want to do this practice, send us an email to gdgclouduae@gmail.com. Just asking the support team to share the email address on the channel. I can't see the email address being shared. Yeah, so if you send us an email to gdgclouduae@gmail.com, what we will be doing, we'll give you credits. And again, the link that you need to go to is Quest 31. Put that in there. Or if you have already credits, then what you need to do is you need to open the console, and you can see here the quick labs, the topics that we talked about here. So they explain to you the HTTP load balancer, the Cloud Armor, the instance groups you can see here. And basically what you will be doing here, you're going to configure, create an HTTP, have check firewall rules, 2 instance templates, 2 managed instance groups, a load balancer with IPv4 and IPv6, do some testing on that, use a deny list on IP address to restrict access to the load balancer. Really good lab, very comprehensive to bring all those pieces together into this practical. I'm just waiting to make sure that everybody is got to this stage. I'm just waiting for sending those. And even if you send us an email later on, we will oblige, like we say, and we're going to give you credit. So I'm just going to show you the process of accessing the console, because what you will find later on is the steps are very well documented, how to access, to apply the steps. So gives you through screenshots on the console, to the PC network, networking, creating firewall rules with all the configuration items that you need to do, the health checks afterwards. And each time you go to a stage, you check progress. So as long as you did these steps according to what I told you, so make sure that you enter the naming correctly, the IP address they ask you to put in, and then what you will find, you put a check progress, it goes green, and it will add the scoring for you here. So we can see here, very well detailed into what you need to do. So make sure you take your time into following this steps for creating the instance groups as well. And make sure also to open this in a Cognito window. So the console, basically you right click here, open link in the Cognito window. And you will be using the username password that you get given. You've got a username here that I can copy in the console, and the password that I can copy. So these are the ones that you'll be using. And then you will be going next. Accept. And pretty much you are given resources to a real environment on GCP. So this is not simulation. And this is the bits that you're going to go create. So on the left side, you've got this burger menu, VPC, firewall rule. You're going to create it from here. The load balancer itself, you go down here. So like I said, this is the console. And for firewall, it's under VPC network. This is where you create a firewall. You're just filling the pieces they ask you to fill in. So when you create one, you give it a name, the network where it's going to apply, direction of traffic, ingress or egress, allow or deny, and the port they ask you to do. For the load balancer itself, you're going to be going to networking services. So I can go back here and load balancers. and it's like a wizard that you're gonna go through from internet to VMs, classic HTTP. You give it a name. I'm not looking at the specifications that we've seen, but basically what you can do a storage bucket as a backend, and also I can, if I go to the backend again, I can create that, give it a name, and to enable Cloud Cdn is just a matter of a tick box. Enable Cloud Cdn for the caching that we talked about, and it's pretty much done for you. So just go back easy. Did we have any emails for? Majid, did we receive any emails for asking for credits? We have. Okay, so for the ones who requested the credits, I'm just gonna be giving you that access now. I'll just go back here. A second. And where is the email addresses? I need to. Credits. Subscriptions. Share credits. Okay, I'm just gonna do that. So have you got the email address that I need to share credits with?
Yes, they sent on the email, on the GDG Cloud Events email.
I don't have access to it.
Really? Okay, I'll forward it.
Yeah, forward it to me. So I'm gonna add those email addresses for you guys to have credits. So give me a few seconds. How many were you talking about?
Only two.
Okay. If you can forward it to my email. So the guys who requested the credits, I'm just gonna add you now, and you should be able to. Oh man. So you got 1 month, like I said, you'll be able to do all the other labs. But if you start with this load balancer with there you go. So let me. I'm just gonna add that. Okay, the guys who asked that, they should be, I only got one. There's another one?
On the private chat.
You put it in there?
Yeah.
Okay, so I'm adding those. So you should be able to have access now. So if you try to, okay. There you go. So you should have credits in order to do those labs. And keep a note of that. Keep a note of that email. For anybody later on who wants some credits, we give them. And again, these are the two information you need to keep here: is our email address and the quest address. So again, yeah, if you log out and log in again, you should be able to this one and the email address if you want to reach us later on to give you some credits. Those two, the cloud skill boost.google/quest/31 and our email address if you need credits in order to do that, even for the guys who would be able to watch this YouTube session later on, they can just use these two pieces of information to reach out to us and go to do that quest. And with that, let me see if there's any questions in the chat. So again, that's it. Yeah. I don't see any questions in there. Okay, like I said, the last pieces of information, just go back to the quest for credit sent email to gddclouduae@gmail.com, sorry. Okay, there's another one. I need to add that, yeah. Okay. So let me. Okay. I did another one. Yeah, all the requests that came through, they've been done. So you should, if you try again, you should be able to see that you have credits, and you'll be able to do the labs as part of that quest. So credits, the quest. Any questions that you have about the services that we covered, please reach out to us on gddclouduae@gmail.com. Subscribe to the channel. We hit the 1 hour for this session. Thank you again. Watch out.